So LiveWires are a bi-monthly series where we talk about SignalWire, Relay, or in general SignalWire. Relay is a very interesting technology, and we've been doing a lot of cool stuff with it. And we're adding parts, we're adding features every time we do an update. We try to cover different use cases, and we try to do real life use cases. So each one of the LiveWire presentations you've seen has been pulled out of a real life use case of a customer or multiple customers. We'll go through a few little. We'll start with what Relay is, do a little explanation of the use case, and then take a look at the demo. And then we'll do a code deep dive. This particular presentation will have a bit more code than usual because there's a lot to see and take a look at because of the integration and how it's working. Cool. So, again, we just did a quick introduction, go through what Relay is. We'll go through how easy it is to integrate Relay with an infrastructure, and especially regarding third-party integrations. That is, libraries or services that you can bring into your app by using Relay as the bridge between your code and third-party services. Then we'll do a live sentiment analysis call, and I will call someone that will act as the agent, and I will complain about something, and we'll see how we get the results in real time from this third-party service that we're using. After that, there's going to be a code dive, and then we'll do a survey, and we'll certainly have time for the Q&A. So please stay until the end, because the one lucky winner that completes the survey will win a $50 gift card. Also stay until the end because it's interesting. This is me. Well, I don't look as good at that photo, which is really great. Someone must touch it up. I'm the lead technical evangelist, SignalWire. I've been doing this for quite a while. I have 15 years of experience in telephony and probably about 10 in doing conferences around the world. So I just like talking to people about the cool stuff that we do at SignalWire. And I'm here to help for any questions. I'm usually on Slack and looking forward to hear what cool things you built too. What else? So what is Relay? Relay is our innovative communication protocol. It's something that's different from many other things that are in the industry, and it's based on WebSockets. What's different is that, generally speaking, using a telephony API means using HTTP. So you get a request from the server, the request bounces back to you, and you tell the server what you need to do, etc. It's a back and forth, and each one of those, even if your network is really fast and if you have very good web server, each interaction can take up to, I think, 200 milliseconds round trip. People will say, I have a server that responds in 20 milliseconds. Well, that means you're doing your job right, but still, it's going to take hundreds of milliseconds for each interaction. So it's making a dynamic application requires a quicker interaction time. Relay provides the same features that you come to expect from a telephony API and more, such as speech recognition, answer machine detection, media manipulation of various types, of which we'll use one today, text-to-speech, and even has messaging. While Relay is suited for everything, including the messaging. But if you're just doing texting, you're probably better off with an HTTPS interface, which is because of how it works. Still, it has messaging, so you can mix and match multimodal channels within your app. It's a complete SignalWire innovation, and for the free switch people, it's meant to be the successor of the ESL protocol. For other people, it's just a very cool thing that you can use to build applications. So we're talking about integrating Relay with your infrastructure. So unlike running an HTTP server that you will have to add to your existing application, maybe add some extra actions and route, Relay runs in its own process. The process doesn't have any open port requirement. I will briefly see that in the Docker file definition later, and also show it in the when it's running. So that means that you can run a Relay process anywhere you like, and it will connect to SignalWire and handle calls. There is no need for open ports, no need for any kind of communication. It's very important because that allows you to deploy a Relay inside an existing infrastructure or application in its own container. We have many customers who said that it's the best thing they like about Relay. It just does its own thing. You can communicate with your application. Of course, once a process is running, you have to be able to tell it what to do, and it has to be able to report on what it's doing. So since it's simply a process written in your favorite language, we support Python, Ruby, JavaScript, PHP, C Sharp, and Golang, and I might have forgotten one, but we'll look at it later. You can communicate through the process via plain HTTP, so Relay can make requests to your web server, which is what we'll be doing in this demo. Or you could be using any processing queue. Say you have a large application that's using a processing queue such as Kafka. Since your Relay consumer is just a normal process written in your language, it can use whatever library. Or we provide a specific mechanism which is called task. C++ is not really on the horizon, but a JSON protocol is actually open source and quite documented. So you can probably have a go at it, and I'd be happy to take a look at it. The idea here is that tasks are a distributed mechanism that allows you to ask SignalWire, tell my consumers to do something, and SignalWire will do that for you. The trick here is that the Relay consumers scale horizontally, which means that if you run multiples and a call comes in, one of them will grab the call and the others will be ignored. So you can have multiples and they will automatically distribute the load amongst themselves. Or rather, SignalWire will distribute the load for you, which makes it very easy to scale horizontally. Even though these are just plain processes processing JSON over WebSockets, so you can do a lot with a little. We have customers who run 2 or 3 consumer processes and handle over 1,000 calls per minute, so you can scale pretty quickly. You will bottleneck on other stuff earlier. No, unfortunately, there is no Rust client on the horizon until we do have a very good Rust programmer on the team. So who knows? Maybe sometimes she'll just decide to do it. So, as we said, Relay has a comprehensive set of built-in features. So we have, again, speech recognition, the ability to do text-to-speech, etc. Multi-channel is enabled. The same consumer can receive and send voice calls and messages, or you can receive a voice call and send a message, or you can get a message and call the person back. You can do anything you can mix and match. You can even do faxing if you really, really have to. It worked very well. I'd rather people use some modern stuff, but our faxing implementation is actually quite good. So check it out. Again, well, built-in features, including faxing if you really need it. But of course, faxing and messaging are less exciting in a sense because really it's just, fax comes in, you get the file, message comes in, it gets a string. Voice is what's really interesting. You can integrate through external services using APIs. Since it's just a plain process written in your favorite language, you can use any library you usually have in your application to interact with existing APIs. Call control is done in real time. And thank you, Eric. Yes, we have a lot of people coming over for Twilio because they deprecated fax. We didn't, and our fax implementation is very good. So try it out. Going back to what we're doing, code control is real time, so you don't need to worry about request and timing. We already discussed that. Each interaction is faster, which means things get started earlier. The process we're going to be using in this particular case is called tap. Tap allows you to send audio to an endpoint from a relay process in 2 ways. One is through RTP, and the other is through WebSockets. In this particular case, we'll use WebSocket because it's supported by many, many third-party services. And before we dive into the code, here's a case study that we're going to do. So this idea is actually extracted with something one of our customers is actually doing. In today's distributed world, as opposed to how it used to be, everybody is working out of a different place. And this is it's very true for call centers too. So every call center used to have everybody in one big room with walls between them, and supervisors could just walk the floor and look at what's going on. Maybe someone will raise their hand and say, hey, I need help here. And all of that is really changing. For, of course, the COVID reasons, but really it was a change that was already in place in industry. Everybody will tell you. So you now have maybe small groups of agents working in different places, or you have everybody working from home. Anyways, relying more and more on what their platform provides them. So it's not just the professionality of your employees any longer, but you also need people to be supported by technology. As an agent, having access to live insights is very useful. So if you're an agent, especially if you're starting out, you've been certainly trained and you certainly know how to do your job because you've been helped by your supervisors. But time to time, you've just started, you have read through your 10 pages of training, something is missing, you are in a case you never really handled before, and you really don't know what's going on. Technology can help you by extracting information from the call as it progresses and displaying it to you in your usual agent screen so that you know what's going on. The goal there is to get people to be able to interact more with the customer without having to be supervised. Other end, though, the other, not I would say problem, but the other challenge is that managers in a call center don't really know what's going on anymore. Sure, you can listen to calls, you can drop in, you can check on reports, but really the problem there is that in real time you have no ability to detect if a call is going wrong before it's too late. Because, of course, again, when it used to be that everybody was in the same room, you could raise your hand and someone, the managers walking the floor, would just come over and see what was going on and maybe take the call or help you with some materials. But right now, everybody's at home sitting in front of their desk and you don't really know what's going on until it might be too late, because even typing a chat message and explaining what's going on, many people do that. We all do that during work, right? You're on a call, but you ask a question to your colleagues and it takes a few seconds between typing, etc. And you also sort of lag, right? So when you're typing, you slow down and people notice you're doing something that's not really listening to them, which is very important in a call center context, especially when you're dealing with customers these days, which can be demanding because people have grown accustomed to a higher standard and they've come accustomed to a lot of things. So what I thought I'd build is extract a quick demo of how a relay call can process audio in real time. So I'll be acting as the angry client and someone will be picking up the phone on the other end as the agent and letting me know what's going on and how I am. I will let them know that I'm unhappy with something and blah blah, and we'll see how the application reacts. I won't spoil the surprise because it's quite interesting. A call using my phone. So hopefully, maybe we hear what's on the other end. So it might cause some terrible echo. So I won't do that. Okay, so now I'm calling someone. Hello, I would like to complain about your service. I think your service is not very good and my package was lost again. You should do something about it.
I'm sorry about that, sir. We're looking into it.
Oh, I'm glad to hear that you can help me. I hope you can resolve this because that package is very important to me and it's my present for my birthday. So, just what goes on here is that so the first one is actually something you should have filtered out. Let me take a look. Let me briefly show you what's on the screen right now. So this is the first interaction I had. This is probably the first sentence I said and trigger something that's weakly positive. So we just is neutral. But second sentence I said, which is actually I would like to complain about your service and service is not very good. You lost my package, etc. And that's the strong negative. So we extracted an entity here. I said service multiple times. So the NLP extraction, there's quite a bit of precision in those scores. I'm not a fan of rounding. Buy better databases if you need more rounding. Sorry, yeah, you're right. So what we're seeing here is that I was complaining about a service. I said service multiple times, and the entity extraction says there's a relevant term in what I was saying, which is service. And this is strong negative. So let's just split this interpretation into two. When we look at the strong negative, this is more for the manager. So actually, a strong negative message could even be a strong negative message could even be something you trigger and send an SMS to a manager. The application actually does that if you have three time negative. But and that's the first thing. So this is how a manager finds out that an agent is having trouble on a call without having to monitor every call. So Luca, I was calling Shefali, our lead of product marketing. Shefali picked up the phone, and her hypothetical supervisor saw that I was unhappy in real time. And then maybe, one score doesn't really make it because it's one sentence. But if there's 2 or 3 negatives in one after the other, it's most likely not that the call is going badly from the agent perspective. The agent is doing their best, likely, but the customer is still angry. No, the sentiment is based on what the user said. Waveform. You could do waveform analysis too. We have customers doing waveform analysis. It just is not a very super easy to use API to integrate with that does waveform analysis. But yeah, this one is based on NLP. So text, speech to text, and then going to the actual interpretation. And then they know what was talking about the service. So this could be used to pull up a knowledge base page, right? So when the agent gets a strong negative result and one of the entities is found in the database, why don't we search the knowledge base for them in a separate window or frame within the screen for that word? So they already know where to look up the issue. So this person is angry about service. Here's your information. This cuts your time, and again, helps the agent not have to type service enter while they're talking to you, which is not easy to do even if you're a very good typer. I spent 15 years programming, and I still can't keep a conversation going well while I'm trying to type something. I will slow down a little. So then Shefali let me know they will be looking into the issue, and I just said, I'm glad to hear that you can help me. That's really just all it said. So that's a strong positive result, and doesn't have any meaningful entities, because entity extraction will look for the word that it considers relevant. So if you say something, I'm glad to hear that you can help me, nothing there stands out, and you agree with me that there's no special word in there. Had I said something like, I'm glad to hear that you can help me with my delivery, maybe we'll have picked up delivery because it's not a common word. This is all done through NLP. And it's in real time, which is the most important part. So going back to our code, our relay consumer accepts calls and sends audio to the NLP service. There's a web application, which is the one you were looking at, that monitors the alerts in real time. When a call has 3 consecutive negative results, relay will dispatch an SMS to a supervisor. That's actually probably not configured on the current version I'm running, but it's there. And that shows the multimodal. So the service is extracted automatically using a statistical database. So it's actually effectively something like a noise detector for words, which is, for lack of a better explanation. It's possible to pass. Many services allow you to pass in extra knowledge bases. So you can do both. You can do both for sure. The easiest thing is to pass in a list of keywords. You generally have, 10, 15, 20 keywords in a business, right? So you pass in those, and those will be looked after with more attention. Cool. So how does this all this thing actually work? I'm glad that you asked. I have code for you. So this is a Node.js application written around our relay consumer, and a few other things. What we use here is, in this particular case, it's using Google ASR. But again, this is really just because I built the application like that. You can do many other interesting integrations. Symbol.ai comes to mind. There's a few others that are very, very useful. And I'll be doing more in the future because this has been very interesting to me. So how we do this is, let's look at the consumer first. The consumer, as you'll see, is super duper simple. A consumer is the code unit that you run on your own network to connect to SignalWire, and it will accept calls. The important lines are here: context, office, context is a category of destinations that you have set up in the SignalWire dashboard. So I assigned a phone number to the office context. So whenever a call comes in, it hits any consumer that says, "Hey, I'm waiting for calls from the office context." Then there's some enabling debugging here, and after we answer the call, we start a tap. This is the important part. We specify we only want the spoken part, speak part. So the direction can be speak, listen, or both. Of course, since this is a simulated inbound call center, I want to know what the caller is saying. I could do listen, and I could listen to what the what the agent is saying, or I could do both and I get both in the same stream. I recommend, if you want to do both, I recommend doing speak and listen. You can do multiple taps. So I could have one tap for the agent and one tap for the caller if I wanted to. You can do any one because these are async, as you can see here. So they're asynchronous. You would just add another with different parameters, and you would have two different WebSocket streams going out from your application to your other stuff. And then we just call into the destination number. I hard-coded this for the sake of simplicity, but of course, this could be pulled by a database, and this should be pulled by a database or something. This is the agent number, effectively. Then we just wait for the call to end because everything is async here. So unless we tell relay to wait, it actually won't. What else? This is the more or less the starting this is more or less the starting point, and we can take a quick look at the application. The application is just set up using Fay, and which is a WebSocket library in JavaScript, and it's using Express as the web server. So nothing complicated. What I wanted to show, more than the code, which you can go look at, it's pretty complicated but quite interesting. I wanted to show you how the Docker Compose is built out as the last thing. So maybe not everybody knows what Docker is. Docker is a container system. So it allows you to run each one of your applications in a separate container, which is effectively like a micro virtual machine, a micro server that isolates the service, allows you to specify resources, allows you to do a lot of interesting things around it without having to manage application state, deployment, etc. Just goes up and down. Allows us to distribute applications like this one in a way where you can just type in your environment variables and get going, and it will just start. But more important, as you can see here, I'm binding one. This is the web servers, the one we're using there, and we're only binding one port, which is port 5000. This will be your web server. So the web service will be what you already have, in a sense, right? And the relay consumer needs no ports. It would just start and run without any particular requirement. So this means that you can just set relay there. It will not do much by itself, but it will take calls, and you can go from there, expanding into your own app without having to do anything special. In our particular case, the special, let's take a. I know you want to see it. The special sauce is somewhere in here in the various libraries. So the NLP library takes the sentiment result and does the various computations that you saw here. I don't believe so. This is the interpretation we do, and the ASR is actually done here. So as you can see here, if you go look at the code, I mean, it's sort of complicated, so I won't dwell on it too much. But the point is, here in this block, starting line 155, we just get audio from the backend. We publish updates, or we just write it to the input stream. This is the crucial part. This could be, again, any other service, Symbol.ai, Watson, AWS, whatever, Lex. You can do whatever. It's just I used one provider just because I had to build one demo. The goal here is to get it going very quickly, and I think this is this is almost a product. Like, you could probably just try and run it and see what happens. Just add a little bit of developers, etc. It's a raw audio stream. You can, of course, you can always specify the encoding. So it's not shown here because it's complicated. Well, I didn't want to complicate it too much, but you can request SignalWire to send you audio in a specific codec and rate. So this one is 8K PCMU because it's a phone call, but you can do you could request 44K opus. It will be heavy-ish. So I'm not even sure you have a backend that's able to process that. But if you're actually not processing the audio, you're just relaying it to somewhere else, you can require higher quality or different codecs. So that's worth knowing. That's really it. There's a lot to talk about in Relay. So what we want to show is how easy it is, again, to go and integrate Relay in an existing service so that you already have a call center. You're just tapping out calls. So you just get the audio out from Relay and do whatever you want with it and return insights to your agents and managers so they're able to work on whatever they need in this newly distributed world, which has been a surprise to many, but SignalWire is here to help. We've done a lot of work on this. We have the languages supported are JavaScript, Python, PHP, Ruby, C#, and Golang. I wrote this in JavaScript because I had to pick one, but my favorite language is Ruby. Cool. So I think that's it, really. So there's an SDK you can use, for everything. Plus, there's a JSON protocol that's published, so if you really feel adventurous, you can probably build your own in WebSockets. Okay, so as we saw here, we have a consumer and a simple web app. Everything is going through WebSockets. Using Docker allows for easy deployment. Look into Docker if you haven't used it yet. It's very, very useful. Most of our examples include a Docker container component, so you can run it right away. And the full code for the application is available at that link, which I also posted in chat earlier, and I'll just repost it now so you can see it easily. Of course, there's also a link to the slides. Cool. So this is, it's easy to get started. Take a look at we do have starter Docker Relay images complete with a consumer that doesn't do too much, but it's pretty helpful. And at the URL, and which I'll paste in the chat shortly if this doesn't break horribly. Okay, I'll paste it later. And you can get started on Docker without installing anything, or you can get started locally. It's really not complicated because you don't even need an ngrok tunnel. You don't need anything. You just get it going. But still, take a look at the Docker images and let me know how we can improve those. So the language support is actually comes from the backend, not from Relay. So we just send the raw audio and raw media to the backend, whatever it is, and depending on what the backend supports, it will support different languages. It's I think many services support English and not much more from the natural language programming perspective. If you're looking for pure ASR, so speech recognition, the cloud stuff is probably like Google or Amazon or Azure is probably more well suited. But the NLP stuff mostly is really only in English right now that I've seen. Cool. So question time. There was a lot of questions during the webinar, but I'm super happy to fill more. Anything you'd like to know, I'm very happy. And the winner from the so we'll send out an email soon with all the links and recordings. So anyone who needs it will get it soon. And we also have a YouTube channel where we be publishing this, right? Perfect. Yeah. So that's gonna be cool. Yeah, that will be my first YouTube channel. So any questions, anything I can help you with, anything I can point you at, or if you'd like to just poke at things and see how things go, feel free to just take a look at the code, poke around, see what it's doing, and let me know how I can help. We're here to help. I'm most often on Slack, the community Slack, or you can find me an email. The JSON WebSockets implementing in another language. I'll find you a link because that's changing. So I'll get you a link because that documentation is getting published. Final version is going out in a couple of weeks, but we do have a beta somewhere. So I'll take a note and find you a link later. And what else? I hope you had a good time. I love Relay. We've been doing a lot of interesting stuff with Relay, and it's been a very fun ride. Yeah, this still says TBA, but when will our next LiveWire be? Actually, the end of the month, March 31st, right?
Yes, that's correct. March 31st is the next LiveWire.
This is the power of cloud computing. See, nobody saw anything, right? not being recorded, right? Cool. So nobody saw anything. That's March 31st, right? And so NLP is performed by a third party. We just send the audio over. This is just an example of how to patch the audio out from a call. And we do have our own speech to text and text to speech service, so it's fully integrated. So you could even do something fancier. So we actually have a customer who exactly does that. They pipe out the audio to an external service, and then they speak the results back to the customer via our text to speech. So you can do some quite complicated. Yeah, so TTS supports. I think so there's male and female, but I think we recently added a switch to support another half dozen of different tones. So we have multiple voices. So we did a couple deep dives into Relay webinars, which are recorded on the YouTube channel. So we can probably find you a link for it. And on the 31st of the month, I will be doing a deployment workshop with Relay, which will be quite of a purely technical deep dive. But there's also another LiveWire on 31st, which is the campaign registry. Campaign registry is all you need to know when you're doing messaging in the US. Right now, you need to be registered in a campaign registry so that your messages get delivered. SignalWire can help with that. We have a long experience with that. We have one of the best teams in the business about getting the campaign registry working for you. So if you're into messaging or you're looking to do messaging at a higher scale, don't miss it.
And the link to register for the LiveWire is in the chat, so you can find it there. For all the rest of the LiveWires for April, can't believe it's already April soon. We will be sending out an email, so keep an eye out for that.
Thank you very much, Shefali. Well, thank you very much, everybody. Actually, it was a great session, and I hope you had fun. And we saw how to augment the call center using Relay. And any questions you have, hit me up. I'll be here.
Luca, have you announced the winner yet?
No, I haven't.
Okay.
You want to do it?
Do you want to go ahead and announce it?
So it's Marco.
There you go.
You get an email soon. Congratulations, you get an email soon with the instructions. And thank you so much for joining us.